Hello everyone and welcome to day 32 of the Jamb Physics in 40 Days series. We want to say a big thank you to those of you who have made it a date with us every day to follow our videos on this series. We want to believe that the videos have been helpful so far, and please do not forget that if you have any question at all, we are really interested in your questions, so please keep them coming. Drop it in the comment section and we promise to attend to all of your questions. And if you're seeing this video for the first time, this is Jamb Physics in 40 Days. It is a series that is brought to you by Oya Learn, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to gather all the necessary skills and tools that will help you ace Jamb Physics. So peradventure, you're a candidate preparing for the next Jamb exams, and of the subject combination, one of them is physics, then this video is specifically made for you. Now, what we have done in each of the videos is that we look at the individual topics that are in the Jamb Physics curriculum. Now, we'll break down the topic and then we go on to solve past questions on those topics while giving you tips that help you solve questions like that with greater accuracy each time. So you see that if you're able to look at all the videos in the series from start to the end, you should have everything that will help you score a good grade in Jamb Physics. So you do not want to miss any of the videos in the series. Please check out the videos from day 1 to the end. This is day 32. The series will soon come to an end and you don't want to miss it. Please keep checking it out. And because we have a goal to reach so many students, we'll be pleading with you, if you are not subscribed to the channel yet, kindly take a moment to click the subscribe button and also help us by liking the videos and sharing them so that we can meet our goal, which is to reach so many students who are in need of content like this. So please subscribe, like, and share the videos. And if you want to make sure that your learning experience is even more fun, we have this app for you known as the Exam Fun app. The link to download it is in the description box of this video. Kindly click the link to download the app today. One thing about the app is that it is both exciting and rewarding as it infuses fun into your learning time. You get to solve questions on any subject of your choice at different levels and you earn points and also earn some money as you do that. So you are both learning and also earning at the same time. So please click the link, download the app today. Trust me, you're going to enjoy learning with the Exam Fun app. Now, what we have for day 32 is electrical energy and power. Now, what Jamb expects of every candidate on this topic as follows. They expect that every candidate should be able to explain the concepts of electrical energy and power. Now, what electrical energy means is the amount of work done per time when a current flows through a circuit. While the electrical power is defined as the total amount of energy that is either consumed or produced in a circuit. So now the two of them are very different from each other. Electrical energy is measured in joules or kilowatt hour, while electrical power is measured in kilowatts. Now, the reason why it is done this way is because you should be able to convert this into very useful information. And even though, yes, the SI unit for power is watts, but when it comes to electrical power, it is measured in kilowatts. So please take note of that. There's quite a difference there. There are some times where you'll be expected to work in watts, and there will be some times where you'll be expected to work in kilowatts, and then for energy in kilowatts hour. When we start solving questions like that, I will explain the purpose behind that. So please stay tuned for that. Now, secondly, you're expected to be able to solve questions on commercial units of electrical energy and power. Now, I have mentioned that electrical energy is measured in kilowatt hour, while power is in kilowatts. Now, we should be able to calculate the amount of energy consumed, and then we should be able to calculate even the amount you have to pay for consuming such electrical energy. Now, those who are familiar with paying the bills on electricity, you may wonder, how do you determine the amount you have to pay per time? It's all dependent on the amount of power that you consume by the hour. So that is why it is measured in kilowatt hour. because the amount of kilowatts you consume in 1 hour determines the amount you pay for your electric bill. So you should be able to do these calculations. I will solve questions on this given some specific units, but if you're really interested in this, I advise you also check our video on the channel on electrical energy and power. We touched some bases there where we mentioned different rates of energy at different countries also. You can look at that and then pick the one that is to your country and apply it to the calculation. You should be able to estimate the amount of electrical energy you consume in your household, and also the amount you should be paying monthly or even daily if you like on electrical energy consumed in your household. Now, thirdly, you should be able to explain electric power transmission. Now, let me break this down a little bit. You see, when electricity is being transmitted, now from the point where it is produced, now even though we may not mention that so much here, you should know that electrical energy can be produced in so many ways. There is the solar electrification, there's the hydroelectric power plants, there is the thermal power plants and the likes like that. So when they are produced at those power plants, it needs to be transmitted from the plant to sublets of the electric transmission companies. Now, when they do that, you see, they use this kind of wires that we call the power line. And you may wonder, why is it that it's that big? Why is it that the voltage is so high? This is because as electric current is moving through a wire, it generates heat. And when you transmit energy over a long distance like that, with the amount of heat that will be lost, it will lead to a drop in the amount of energy that is transmitted. And if you don't want that to happen, you have to ensure that you limit the amount of heat that is dissipated through the wires. So what they do there is they ensure that they transmit energy at very high voltage. Let me note that here. Very high voltage and very small current. Now, the trick is the lesser the current, the lesser the electrical energy that is lost. Now, this is what binds this. I believe you still remember the laws of conversion of energy, which says energy is neither produced nor destroyed, but it is converted from one form into another. So when you are transmitting electrical energy from one point to another place, heat is being generated from that energy. So the electrical energy will be producing some amount of heat which will be lost to the surrounding. So as it travels like that, the amount that is lost per time is really essential to what you get at the end of your transmission. So you want to limit the amount of energy that is lost through heat, and that is why they do it this way, so that they don't lose so much of it through heat, and most of what they are transmitting from the start point will be gotten at the end point. This is why it's transmitted at very high voltages and extremely small currents. You should understand that concept. And Jamb also expect that you should be able to explain the heating effect of electrical energy, even though I've mentioned it here, but they expect it to be more specific in the sense that we use this in some particular kind of devices like the electric iron, like the electric boiler, like the electric stove and the likes. They rely on the heating effect of electric current to be able to produce heat that can be used to cook, to boil water or other materials like that, and even to iron your clothing. So that's the concept behind this particular subtopic. Now, another thing they expect is that you should be able to explain the concept of electrical wiring in houses. Now, some of the calculations we've done, I think in day 31, we mentioned parallel connections and series connection. Now, what you should know is that when you have series connection, the voltages add up, but the power drops. But by the time you have parallel connection, the voltage remains the same, but the power produced in that circuit is even more. So this is why you have to understand which kind of connection is better for electrical wiring in the house. And then I think during the 30 or the 29, we did mention a part where we talked about when you have light bulbs connected either in series or in parallel, what can happen if one of the bulbs go off. And I mentioned that when you have series connection and one of, like for example, if I have 4 lights in series, let's say this is one of the lights connected to another, connected to another, connected to another like this. If this one should go off, by the time I switch on, only this will come on. You see these two that are perfectly good bulbs will not be able to come on because this has broken the circuit. However, if you have it in parallel, such that you have light bulb 1 connected to light bulb 2, connected to light bulb 3, connected to light bulb 4, and then this being the source of electrical energy. By the time it goes through, if this one goes bad, the energy will still run through the circuit and these 3 will still come on. So you see there that parallel connection has a lot of advantages when you use it in the wiring of houses. So it's important that we understand this concept. Now, that does not mean that series connection is a bad connection. Every type of connection has its own advantages and its disadvantage, which is why it is mentioned as part of the subtopics here. So you should be able to state those advantages and those disadvantages and be able to tell which connection is better for a household, which connection is better for industrial use, and so on like that. And then finally, you should be able to explain the uses of fuse. Now, you see the fuse actually contains a thin wire that whenever there is a surge in current, it melts and cuts the circuit so that that high current does not get to the device. This is why you see highly sensitive devices make use of those fuses a lot because they don't want to get damaged. In an attempt to save money, those fuses are added so that whenever there is a current surge, that high current does not get into the device and destroy it. So before it gets there, the fuse is going to absorb that current and then melt off. And the moment the fuse melts, no current will get to the device. That way it protects your device. And the only thing you have to do is just change the fuse. And the cost of a fuse compared to your device is really very different. So that tells you that fuses are very important, especially in places where there is usually fluctuations in the current. So now, having gone through this, it's important that I mention that there's definitely going to be some parts of this that I have not mentioned so far. But if you want a fuller detail of all these subtopics, I advise that you check out our videos on electrical energy and power. Now, each of these subtopics were treated in that video individually, and then we give you several examples on each so that you will be able to touch all the base on everything that is expected of you in each of this topic. Now, but for the purpose of preparing you for Jamb, what we'll do now is we'll look at some past questions from Jamb on electrical energy and power. Now, they're going to highlight this topic as well, and then as we begin to solve it, I will make mention of some of the facts that I may have skipped, and I'll also be giving you some tips also that will help you solve that question and any other question like that with great accuracy each time you see such. So if you're ready, get your materials, and then let's solve some questions on electrical energy and power. Which of the following instruments consumes the highest current? And then we have 4 instruments here: the electric iron, the television set, the torchlight, and the immersion heater. And we can see the amount of voltage here: 250 volts, 220 volts, 6 volts, and 110 volts. And then the power is 1 kilowatt here, 110 watts, 30 watts, and then 500 watts. So let's find out which consumes the highest current. Now, you should know that power equals the product of current and voltage, which implies that the current is therefore power over voltage. So let's start for equipment 1. For equipment 1, the current equals the power, which is 1 kilowatt, that is 1000 watt, divided by 250 volts. Now, this would give us 4.0 amperes. Now, equipment 2. For equipment 2, the current is 110 watts divided by 220 volts, and this would give us 0.5 amperes. Now, equipment 3, that's a torchlight. The current is 30 watts divided by 6 volts, and this will give us 5.0 amperes. And then finally, equipment 4. The current equals the power, which is 500 watts divided by 110 volts. Now this would give us 4.55 and so on amperes. So now we see the amount of current that each of them consumes. Now the one that is highest, of course, is the 5.0 amperes, which is equipment number 3. That is, the torchlight consumes the most current. So our final answer is 3, which is option C. What is the cost of running 5 50-watt lamps and 4 100-watt lamps for 10 hours if electrical energy costs 2 kobo per kilowatt hour? Now, this kobo, 100 kobo makes a naira. So, and we see that the options here are in naira. So, it means whenever we get our answer, we have to convert it from kobo to naira by dividing by 100. And since we have 5 50-watt lamps, that will be 5 times 50 to give us 250 watts. And 400 watts, that's 4 times 100, that will give us 400 watts. And then we have to bring that to kilowatts before we can then complete our solutions. So this is what we do. We first start by getting power. The power is therefore 5 multiplied by 50 watts plus 4 multiplied by 100 watts. And this would give us 250 watts plus 400 watts, and that is 650 watts. Now the power can then be written as 650 divided by 1000, and that will give us 0.65 kilowatts. That's the total power consumed. Now to see the energy would then be 0.65 kilowatts multiplied by the time in hours. So that will be 10 hours. And this would give us 6.5 kilowatt hour. And since 1 kilowatt hour costs 2 kobo, then the cost of 6.5 kilowatts would then be 6.5 multiplied by 2. And this will give us 13 kobo, which is basically 13 divided by 100 to give us 0.13 naira. So the correct option is D. Which of the following can be described as high tension transmission? Now this refers to how energy is being transmitted from one point to another. And to achieve this, you have to do that at a very high voltage and a very low current. However, sometimes the question could be tweaked in such a way that you are focusing on resistance. You also have to remember that resistance is directly proportional to length. So meaning that if you're transmitting over a very large distance, the tendency for resistance to be very high is also very high in that case. So that is, there should be high resistance as well in order to produce very low current with a high voltage. But as far as this question goes, we see that in the options there is an option that gives us low current and high voltage, and that's just about enough. But if you find any other question like this, but instead of having the current here, they put the resistance, know that the voltage is high, the resistance is high, and the current is very low. So the answer here is option B. Electrical power is transmitted at high voltage rather than a low voltage because the amount of energy lost is due to. Now the energy lost when you transmit at low voltage instead of high voltage is due to heat dissipation. So the answer to this is in option A. Which of the following is an essential physical property of the wires used for making fuses? Now, I did mention that when it comes to fuse, what it does is that whenever there is a current surge rather, it becomes really hot and then melts and breaks the circuit. So that tells you that it is something that has a low melting point. That is, the higher the heat, the quicker it breaks. Okay, so the property of the materials used to make such wires is dependent on the low melting point. So the answer is option D. Questions like this can be a little bit tricky, so it's important that we pay attention to what is really the most important reason in cases like this. However, I'll try to explain other advantages as regards this particular line of question. So let's look at what the question says. It says, in homes, electrical appliances and lamps are connected in parallel because. Now, there are some reasons why they are connected in parallel. But let's look at what we have here first, then we'll pick the correct option. But I would then mention another reason that you would want to consider parallel connection for home wiring. Now, option A says less current will be used. This is incorrect because each individual device that are connected in parallel requires their current. So because of those branch currents, the amount of current used in the end is usually very large. And then in option B, we see less voltage will be used. Now, this is also not true because all the appliances that are connected in parallel are going to receive the full voltage that is distributed. That is whether it is 220 volts or 240 volts or 230 volts, they all receive the same amount of voltage. So that means this is also incorrect. Now, option 3C says parallel connection does not heat up the wire. Now, this is not entirely true, but because of the kind of options we have here, we can still accept this in the sense that what determines how the wires get heated up is dependent on the amount of resistance offered. That is, the more the load you have, if you overload a circuit, it's always going to get hot. Another thing that can also make it get hot is dependent on not just the number of load also, but the quality of wires that is used. That is, if you use thin wires or you use thick wires, it can also determine how the circuit gets hot. But we understand that yes, this line can be true, but it's just not entirely true. So it's more like a half correct statement. And then option D says series connection uses high voltages. Now this is wrong because when you consider a series connection, the amount of voltage is going to be shared among all the devices. So when some will be getting high voltage, some will be getting low voltage, so it does not use high voltage. So this statement is also wrong. So in the end, we are left with a statement that is not entirely true. But because of the kind of options we are provided here, we have to go with that. That is, the answer here is option C. But take note, there are other purposes, reasons why you can go with parallel connection. One of them being the fact that will help you to independently switch on and off any of the devices. Like for example, if you are within your living room and you want the living room lights to be on while the one in the bedroom to be off, you can easily do that with their individual switch, because in parallel connection, each of the device can be assigned their switch. But in series connection, only one switch is going to work for everything, which is also why if one of the devices is faulty, it will affect the functioning of the other devices when it is in series connection. But for parallel connection, when one is faulty, it just overrides that and then the others continue to work until you fix the one that is faulty. So that's one of the major reasons why parallel connection is preferred when it comes to house wiring. But for this question, we just have to go with the option that we see here that is at least correct enough. Since the others have been ruled out to be wrong, we just go with option C. Electrical appliances in homes are normally aired so that, now to understand this, many of you may have seen it before, where you see that most of the electrical appliances you use, when you check out the plug points, they usually have 3 wires. Now the wires are often red, which indicates live wire, then black, which indicates neutral, and then yellow, which indicates earth. Now it's important that I mention that this color changes depending on the country. Like what we have here is different from what you have in the US, it's different from what you have in Germany, it's different from what you have in the UK. Every country has the color code that they adhere to. In some countries, live is brown, while black still remains neutral, and then green stripes with yellow is their earth. There are some countries where black is actually the live wire, so you just have to understand how this works in different countries. So it does not mean it is limited to this. But what I want to pick from what I've just said here is that now when this delivers the current and then this is the neutral part. What this yellow earth does is that whenever there is any loose charge around the appliance, what happens with electrical discharge is this: whenever a person receives electricity through their body, that electricity that went into their body is looking for the fastest path to get to the earth. And the way it does that, it goes from the hand, whatever touches the electrical life source, and then goes to the heart and pulsates, and then go down to the earth, right? It's always looking for the fastest way to reach the ground. So when you have your house earthed, what happens is that whenever there is any loose current around your appliance, maybe because there is an exposed wire or whether there is a fault somewhere, that current that is loose about is looking for a way to get to the earth. So if it cannot find a path to get to the earth, by the time you touch it, it will go through your body to the earth, leading to what we know as electric shock. So whenever you have this earth wire there, what it does is that it passes through this earth wire and goes straight to the ground. That way, even when you touch such an appliance that has this loose current, you don't get shocked because it is already going through the earth wire to the ground. So it's to protect you and also to protect your house, because whenever there is electric shock, it could also lead to fire amongst other kinds of disasters. So to answer this question, the reason why appliances in homes are normally hurt is so that a person touching the appliance is safe from electric shock, which is in option A. What is the cost of running 7 40-watt lamps and 5 80-watt lamps for 12 hours if the electrical energy costs 7 naira per kilowatt hour? So to solve this, we have to multiply the total energy in kilowatt hour by the cost, which is 7 naira per kilowatt hour. So let's solve. The cost is therefore, first we have to find the total power. For the first case here, we have 40 watts, 7 of them. So 7 times 40 plus, now we have 580 watts, so 5 times 80. Now remember to divide all of these by 1000 so that you bring it to kilowatts. Now multiplied by the time is 12 hours, and then we multiply this by the cost, which is 7.00 naira. Now working with this would give us 7 times this, that's 280 plus 400 all divided by 1000 times 12 times 7 naira. Now this would give us 680 divided by 1000 times 12 times 7 naira. Now when you multiply everything that you have here and then divide it by 1000, your answer is going to be 57.12. So 57 naira 12 kobo. So the correct option is D. A working electric motor takes a current of 1.5 amperes when the potential difference across it is 250 volts. If the efficiency is 80%, the power output is, now efficiency is power output over power input. So let's put that down. Efficiency is power output over power input. So in order to find the power output, we have to multiply power input and efficiency. Now, power input is IV, that is current times time. The current is 1.5 amperes, which is the same thing as 3 over 2. Now, let's multiply that by the voltage across. The voltage across is 250, and then multiply by 80%, which is 80 over 100. Now, let's break it down. 0 cancel 0, 0 cancel 0. 2 here 1, 2 here 4. Now what we have is 3 times 25 times 4. Now 25 times 4 is 100. 100 times 3 will give us 300. So this is 300 watts. The power output is 300 watts. That is option A. An electric generator with a power output of 3.0 kilowatts, that is 3000 watts, at a voltage of 1.5 kilovolts, which is 1500 volts, distributes power along cables of resistance 20 ohms. The power loss in the cable is, now power loss during transmission is given as I square R. So we need the current first. Then when we get the current, we can square that and then multiply by the resistance. So to find I, remember I equals power over voltage. Now this is from the fact that power equals IV. Okay, so from here we can then say the power, which is 3 kilowatts, that's 3000 watts, divided by the voltage, which is 1500 volts, and this will give us 2.0 amperes. Now we can then find power loss. Power loss equals 2 squared times resistance 20, and this would be 4 times 20, which is 80, and it is measured in watts. So the power loss is 80 watts, and that is option A. A 3000 watt electric cooker is to be used on a 200 volt main circuit. Which of the fuses below can be used safely with the cooker? Now, if you're yet to be subscribed to the channel, kindly take a moment to click the subscribe button. It's only going to take a second, and you can also hit the notification bell icon so that you get notified every time we put out a new content. And please, we are urging you, continue to share this content so that we can reach a wide range of audience who need videos like this. So please don't stop sharing. And if you have any question at all you'd like to ask us, we are interested in your question. Please keep them coming. Just drop them in the comment section and we will definitely attend to all of your questions. Now, to answer this question, what we need to know is that to select a suitable fuse for a particular device, that fuse must be rated about 125% of the working current. That is, it should not be below that, and it should not be too far off 125% of the working current. It can be more than that, but not too much, because you want to ensure that if there is a current surge, the fuse will then break such it will not allow the current to affect the device itself. So let's first find 125% of the working current in this case, and then see which of these will work for the electric cooker. Here's the solution. The first thing we want to do is to find the working current. The working current I is going to be the power divided by the potential difference of the mains circuit. So that is, we have 3000 divided by 200. And here 0 cancels 0, 0 cancels 0. We have 30 divided by 2, which is 15 amperes. That is, the working current is 15 amperes, and 125%, that's 125 over 100 times 15 amperes is going to give us approximately 18.8 amperes thereabout. So that is, we can work with an 18.8 amperes fuse, not too far off, not too far less of this. And when we look at the options we have 2, 5, 10, and 20. So the closest we have here is 20 amperes. So that means the answer for this question is option D. However, if we have another option, like for example 19 or 17, I'd rather pick those instead of the 20. You have to be closer to 18.8 for it to be accepted as a working fuse for this device. I hope you understand that, but since these are the limited options we have, we will go with option D. An electric lamp marked 240 volts, 60 watts is left to operate for an hour. How much energy is generated by the filament? Now, many will solve this question by first trying to get the current passing through and then trying to get the energy and so on. But since we already have the power, all you need to do is just realize that energy is still power times time. Because basically what power is work done over time taken. And work done is the same thing as energy. So if work done is energy, I can then say the energy therefore is power times time. And since we see that the options provided here are in the SI units, so since we have joules, it means the time also has to be worked in seconds. So let's work with this and see what we have. So solution, since energy equals power times time, the power is given as 60 watt. Now the time is 1 hour. Now 1 hour is 60 minutes times 60 seconds. So that's 1 times 60 times 60. This is in seconds, and that will give us 3,600 seconds. So therefore the energy is therefore 60 times 3,600, and this would give us 216,000 joules. Now to bring this to standard form, that would be 2.16 times 10 to the power of, now this is 1, 2, 3, 4, 5, so power of 5 in joules. So the correct option here is option D. A car battery rated 45 amp hour is charged with a charger whose rating is 2.5 amps. How long will it take to charge the battery full? Now, if you're not familiar with this kind of question, well, it's quite interesting because the way we solve it, you can also apply it to your home devices like your phones or your laptop. You can actually determine the amount of time it takes to charge them to full capacity. Now, how you have to do this is to check your battery rating and the current delivered by your charger. Now, most phones nowadays usually have 5,000 milliamps hour rating, which when divided by 1,000 will give you 5 amps hour. And chargers have different range. You have the 2 amps charger, you have the 2.5 amps charger, and even nowadays you get up to about 3 amps charger for some kind of devices that charge fast. So those super fast chargers sometimes get up to 3 amps, some up to 3.5 amps. So when you use this, the value I just mentioned now, when you find the ratio between them, you can get the amount of time it takes to charge such batteries to full capacity. However, there's always a plus or minus side because there's always energy lost due to heat. Remember I square R, right? You can also apply that if you know the resistance of your cord, right? But to solve this question, since we already know the rating of the battery and we know the current delivered by the charger, we just find the ratio to find the time taken. So here's the solution. That is, what we have here is time equals 45 over 2.5. And this is going to give us 18 hours. That is, the answer is option B. Now, if you apply this to the regular phones, like what I mentioned, regular phones have battery rating of 5,000 milliamps hour, which is 5 amps hour. Okay, and the regular chargers are rated 2 amps. So when we apply this, you see that 5 divided by 2 will give you 2.5 hours. This is why most phones charge in 2.5 hours to full capacity. However, depending on your charger, you can either speed up your charging time or reduce your charging time. I hope this has been helpful. An electrical device is rated 2,000 watts and 250 volts. The correct fuse rating of the device is, now this question, having looked at the past question, there are 2 types of questions that look like this. There's one that gives you this same first line, an electrical device rated 2,000 watts and 250 volts, and then instead of asking for the correct rating of the fuse, it then asks for the maximum current that flows through the device. Now, to solve that one is different from how you will solve this. Now, let me explain that. So to solve this particular question, you have to first find the maximum current that will flow through the device. Now, the current there, I, is given as power over the voltage. So that will be 2000 divided by 250, and the answer is in amps, and this is going to give you 8 amperes. This is the maximum current. So if the question was about maximum current, I would have stopped at 8 amps. And if you observe, you see that 8 amps is part of the options here. Now, this particular question is saying the correct fuse rating. Now, this is it. If you apply 8 amps fuse rating to this device, every time it is delivering less than 8 amps, the device may still work, especially when it's very close to 8 amps. But the very moment it crosses 8 amps, the fuse cuts, right? And then, even though the device is not at much risk yet, you won't be able to use your device at any current that is slightly above 8 amps, which is why the correct fuse rating usually gives allowance of a little bit above the maximum current. So to choose your fuse rating, we usually apply 125% of the maximum current. So fuse rating is supposed to be 125 over 100 times 8 amps, and that will give us 10 amps. So the closer you are to 10 amps, the better. It should not exceed this 10 amps, because at that point you begin to threaten the device. So when we look at the options here, the closest we have to 10 amps is 9 amps. It's above the 8 amps, which is the working current, but it's not less than that, so it's still safe for the device. So the answer to this particular line of question is option A. In the diagram above, if each of the resistors can dissipate a maximum of 18 watts without becoming excessively heated, what is the maximum power the circuit can dissipate? Now, each of these will dissipate 18 watts. So let us find the current moving through each of the resistors. So now recall that power equals I squared R. What this implies that I squared equals power over resistance, which implies that the current is the square root of power over resistance. So let's find that. The power is 18 watts. The resistance is 2. So we have root 9, which will give us 3 amperes. That's the current going through each of them. So now, to get the power in the entire circuit, that the entire circuit will dissipate, we need to find the resistance, the effective resistance in the circuit. Effective resistance. Now, for this part, we're going to be having 2 times 2 over 2 plus 2. Then we add it, because it's in series with this, with 2. Now, what this implies is that we're going to be having 2 times 2 is 4. 4 divided by 2 plus 2, that's 1. So 1 plus 2, that is, we have 3 ohms in total. So the power dissipated by the circuit, which is I squared R, is therefore, remember the current is 3. So 3 squared multiplied by the resistance, the effective resistance is 3. Now, what we have here is 9. So times 3, and this gives us 27 watts. So the correct option is option A. Now, questions like this and many more can be found on the Exam Fun app. It's an app that is created to infuse fun into your learning time. And what is incredible about it is that it is also rewarding. So please click the link in the description box of this video to download the Exam Fun app today, so that you too can infuse fun into your learning time and also earn a little while you learn. And please, if you have any question at all, don't be scared to put your question in the comment section. We will totally attend to all of your questions. In fact, we are expecting those questions. So please, whatever question you have at all for us, put it in the comment section. We promise to attend to all of your questions. And if you are yet to be subscribed to the channel, I would like to plead with you that you take a moment of your time to click the subscribe button and also hit the notification bell icon, so that you get alerted every time we put out a new content. And as always, don't forget to like the videos and also share the videos, so that we can reach a wide range of audiences that are in need of content like this. Thank you so very much for being part of the series. This brings us to the end of day 32. The series continues in day 33. Thank you so much. I hope to see you then. So bye for now.